Okay. Let's just wait a little bit while some people are coming back. I'm just going to quickly. Okay, I decided to type it. Please confirm you can hear my voice and you can see my screen. That way we can at least start typing it. Okay, so we said we have steps. Let's call it rules. And then the rules will be step 1. And under step 1, just leave it like this. At least I know. Okay. Swap. Are you guys back? Can I continue? May I proceed? Or should we give a few more minutes? Okay, let me explain what is going on here, and then I think we can now start the session. Just show the slideshow. Okay. Right, I think most has returned, so I will proceed to explain. I tried to type it as well, so that at least we can follow some of the rules that we have. I saw that there was a pen here, a pen that we can use, and maybe that will help. So for those, I've now used some of the things we learned in the beginning. We have ij, and please note that I, when we say I, this is equals to our row, okay? So normally I is like row 1, all right? In most cases, we want to say, okay, I is the row, but in this case, the I will be our row 1. Our J will be our column 1. Okay, and we also have our N, which refers to our this. Sorry, this is a pointer pen. Column. And that is spelled correct. Then the N will also be our column. Okay, the last one. Yes.
So wait.
I'm listening. Okay, you just went silent.
Yes, sir. Sorry, sir. So I wanted to ask, like, the video that's posted on YouTube. It's not they're like showing 1 year ago.
Yeah, it's not the one I had. So that one was already available. So I haven't uploaded the new ones yet. I explained that to upload the new ones, I must go to Windhoek and then upload with the internet there that is unlimited, because here they are charging me 350 for every upload. And I was told by other people I'm overusing the internet, so I must be very cautious. But I will definitely upload. All the recordings are there. I've stored them, so I will make a plan and upload them. I said by Thursday, I should at least have uploaded most of the things, so that you have at least time on Thursday to prepare for the test Friday, which you can take almost all day Friday. All right. So please note that I've just renamed the things over here to fit what we want to do. So this Aij, this just means the element. This is the element, the number in row 1, column 1. That is that element over there. This element is now row 2, column 2. That is the MN. And that is what we are saying there. So if we say swap, that means that I actually should draw in the swap as well, so that you can see what it means. So if we ask you to swap, then that means step 1. I'll just call it now this to swap. Swap means that you will end up with a matrix that looks like this. You will have in the first element, you will have MN. Whatever that number of MN was, that will now be in the first position. And then in the last position, so here I will have A, MJ, and here I will have A, IN, and here I will have A, IJ. IJ. And that is what the swap means. So we change, this one will go here, and this one will come here. That is what the swap means. So we change them. Whatever the number is there, That's why I'm using algebra letters now, because we don't have any numbers in them. So you will just swap them. And then we said multiply, the next step is multiply AI in, or that is now the I in over here, and the AMJ, which is the AMJ over here. You will multiply them with a -1. So whatever this number is over here, this is now for step 2. Once you first swap, and then the next step, you will multiply this by a -1 and this by a -1. All right. So then we have now completed the adjoint. So at the end, you will have for an adjoint. So if I call this a adjoint, then this will basically equals, if this is the adjoint, let's call this, we said it was called matrix B, right? So adjoint of B will therefore be equals to the following algebra ways. We will have A Mn, all right? And then we will have minus bracket A in, okay, In, and then we will also have minus bracket A Mj, and then we will have the first element in the column, which is A Ij. All right. So it looks crazy now, but I will put some numbers into it so that we can at least see again how we can solve this by using numbers as well. All right, so let me just clear these drawings as well. So if we have another example that I will be using, let's say we have 4, let's say we have -2, let's say we have 3, and let's say we have 5. Okay, so if I have this matrix here, let's call this matrix M. Okay, so if I have matrix M here and I have to find the adjoint of M, so the adjoint of M. Okay, so the adjoint of M will therefore be equals to, we will first do the swap. So I will have a 5. So the 5 goes to where the 4 is, and the 4 goes to where the 5 is. That's the first swap. And then we say we multiply the -2 by a -1. So -1 times -2 will just give me a 2. And 3 times a -1 will give me a -3. All right, so this is basically how we will do the adjoint of a matrix. All right, so you have your matrix, then you first find the adjoint. So you swap those things, and then you multiply -1 over here, multiply -1 over there. So the signs and the numbers slightly change. Okay, and you will notice that this is not the same as the transposed of a matrix, because the transpose of a matrix just says your rows will become columns. Okay, and your columns will become rows. Okay, so M transpose, which will be M1 over here, will therefore look like this. You will have 4 minus 2 over here, and then you will have 3 and 5 over here. This is M transposed. Okay, so you have M, which is the matrix, M transposed, adjoint of a matrix, and we can now also find the determinant of M. So the det of M, I call it det, all right, of M is now therefore equals to, we said we cross multiply and then subtract. So it will be 4 times 5, all right, minus 3 times -2. And 4 times 5 is 20. 20 minus 3 times -2 is -6. So it's -6, and we have 26. So you can see now how one matrix has 3 different things that we can get out of it. And that is not even it. We are not done yet. So from these things that we have here, we can now therefore go and find the inverse of a matrix, which is called M-1. So the inverse of a matrix is where we are going to now. So just to recap again, so in order for us to get the inverse of a matrix, we need the adjoint, which is the one over here, and we need the determinant, which is the one over here. Those two are the ones that will help us to get the inverse of the matrix. Okay, so just again, the adjoint, the steps is just swap. the first element, which is this one over here, with the last element, which is this one over here. You swap them, all right? And then once you swap them, then you multiply the other two elements by a -1. Whatever they were, you multiply them by a -1, and then we get the adjoint, all right? So the adjoint of a matrix is, they say it's the easiest thing to do compared to the determinant, because we just swap and multiply by -1 on the opposite diagonal. The main diagonal swap, the opposite diagonal or the other diagonal, we multiply by -1. And you will see in most other textbooks, let me just explain that one again. Erase all. Let me just explain the other way we can do the adjoint through an example is the following. You will have, let's say this time we have 3 minus 4, 7, and 2, all right? So what they do for the adjoint is you will first swap. The first rule is always to swap the main diagonal. So you will swap the main diagonal, all right? So to swap, we will end up with something that looks like this. 2 minus 4, 7, and 3. That is the first swap. And then what they do is they tell you to multiply it by this matrix, all right? You multiply it by a 1, a -1, in a sense of something like this, where it's either not multiply, but you replace the signs, all right? Not actually multiply, but replace the signs. Let's say pointer eraser, because multiplication will give you another answer, all right? Pointer pen. So we just replace, if this we normally call positive, right? This is just negative, all right? So they say replace each of the signs with the following one, okay? So then you will have for the 2, is it positive? And it's a positive here, so the 2 will stay a positive. The -4 is a negative, so we multiply by a negative again. So it's more of a multiplication, but not the normal matrix multiplication, because here it's just a normal +1. So each element here multiplies each element inside here. So this is actually what do we call it? This is actually, all of them are invisible ones that you will see here, okay? And I don't want to say multiply, because multiplication told us it must be row by column, and then you will see it will give you a different matrix at the end, okay? So here you will see that the 2 over here is going to be multiplied by the +1, which is just going to be a 2, which is this one over here. And then you see that the -4 is going to be multiplied by the -1. So -4 times -1 will give you a +4, which is that one over there. Then we go to the 7. The 7 over here will multiply the -1. So it will give us a -7. And the 3 will multiply the +1, which will just give us a 3. And then you will get your answer over here. So this is normally how some people will explain how we get to that -1 that we have over here, which is step 2 that we are trying to explain. So, but the easier way is just to say this 2 diagonals swap, the other diagonals multiply all of those values by a -1. We will still end up with the same answer at the bottom, which we are having there now. Okay, so that is basically what we are talking about. So these examples that I have put up here is for a 3x3 matrix, and we are not going to do 3x3 matrix yet. So I will skip this example for now, because we will have another example where we have an inverse of a matrix of a 2x2 one. We just want to explain some of the things again. So we have there. So a square matrix, it must be a square matrix, means it must be either 2x2, 3x3, or 1x1. So that's why the examples I have here is a 3 by 3 matrix, 3 rows, 3 columns, all right? But you guys will only do 2 by 2, all right? So don't worry about most of the calculations, but all the steps are the same. So square matrix, and then it must be non-singular, meaning that the determinant must not be 0. And every inverse of a matrix possesses a unique inverse. This is important. The inverse of one matrix is not equal to the inverse of another matrix, all right? So what we will see here is an example that I will now explain, and then we will test the inverse, and then we will look at the example as well to test how it will come back. So to test if an inverse of a matrix is an inverse, we will then say, let A be an inverse of a matrix of order n by n, right? We don't know what the n is. Let B be, and C be two inverses of A, all right? So when or then, if we multiply A, which is the matrix that we have identified, by B, which is equals to the same as B times A, okay, it will give us an identity matrix, okay? So that is now where the identity comes from, identity. So in here, IN for identity matrix. And then the same for the C. If we multiply A times C, it will give us the identity matrix. And we spoke about the identity matrix for a 2 by 2 being 1, 0, 0, 1. So when you multiply a matrix by its inverse, you will end up with an identity matrix, which is this 1, which is true. If I have, this is identity, it's called an identity because if you look at the determinant of this, the determinant of the inverse is always going to be 1. And if you look at any identity of anything, if I say A multiplied by A to the power of -1, all right? This is the identity of A in algebra. This is now just normal algebra. Then you will now say A to the power of -1. We talked about this in class already, is equals to 1 over to the A to the power of 1. All right, we spoke about this in class. And so this means that it's A times 1 over A. And if you multiply this together, you will get A over A, and then you will get 1. All right, so this is where that identity thing comes from. If you multiply anything by its inverse or complement, you will get a 1. That is now where this proof is coming from. So we are going to have a calculative example here where we calculate the inverse from the beginning until the end, and we also do a test if it will be true or false. So I want you guys to give me a 2 by 2 matrix example that we can test with. Maybe 2 examples would be nice. Just any matrix that comes to your mind in a 2 by 2 form. Anyone to give us an example? This will be an interesting way, just to show you it will work for anything. Do you have numbers? I mean, like, give us a number that we can put in here. Let's call this matrix X, okay? Give us numbers to put in the matrix, guys. Any numbers that you have, preferably different numbers of different sorts, so that example will be easier to do. Okay, so I have a -8. I have a -2. I need 2 more numbers. These are the numbers that I'm getting. I need 2 more numbers. Anybody else? 2 more numbers, just any numbers that you have, positive, your lucky number, or doesn't matter what we have. Yes, a 4. And the last number, a 7. All right, thank you for those 2 numbers. Let's get started with this. So first, we have to find the inverse, right? Okay. Not sure. Okay. So there's supposed to be an E at inverse. I think so. All right. So first, we are going to find the inverse. All right. Of the matrix. All right. So we are going to look at the inverse of the matrix, and to get the inverse of the matrix, we need to follow certain rules that we have set. So we need to know that for any inverse, you must have this formula 1 over the determinant of that matrix, okay, whatever the matrix is, multiplied by the adjoint, okay, adjoint of that matrix. This is the formula that we will be using. So to get the inverse, we need to calculate the determinant, we need to calculate the adjoint, and then we get the inverse. So let us do the calculation first. So what I normally do is when we give you a matrix like this, you first start by saying that equals 2, and then you will also say adjoint equals 2. So that is what we first need to get before we can even calculate the inverse. So determinant cross multiply. So it will be 8 times 7, which is 56. All right, I'm not writing down the whole things. I'm now just calculating out of my head, minus 56. And then we minus it by 4 times -2, which is -8. So it will be 56 plus 8, minus 56 plus 8. And this I'm going to write on this side because the space is finished now. So minus 56 times 8 will give us an answer of should be 48. And that will be a minus. All right. So I hope you got the determinant part quickly as well. This is now how we are going to be basically doing it in what we call it in the exam paper. Okay. So we got the determinant, which is minus 48, and we notice that minus 48 is not equal to 0. Okay. So that means we can find an inverse of this matrix. And then we do the adjoint. So the adjoint is the flip and the minus that we have to do to the matrix. So we flip the 8 and -8 and the 7. So the 7 goes on top. The -8 goes at the corner. That's the flip. And then we multiply the other 2 by -1. So this will be a 2 and this will be a -4. So that is how we get the determinant. That is how we get the adjoint for any given matrix. So you can see the calculations is fairly simple and easy. And we will also give marks for these calculations if you have them correct as well. Excuse me. So now let us now go into calculating the inverse. So therefore, to get the inverse of x, we said that x inverse is therefore denoted by like this with a -1 on top. So x inverse equals to 1 over the determinant. Determinant is now minus 48. All right, multiplied by the adjoint of the matrix. So the adjoint is the 7, 2, -4, and -8. That is the adjoint. So over here, we know this is the where we got it from. It's now just this answers that we got. And now we just now simplify. We do the scalar multiplication. So 1 over this multiplied by everything inside the bracket. So we will have the following. I'll just make the matrix a little bit bigger over here so we can fit in. So I will have minus 1 over 48 times 7 will give me 7 over 48, and this is a minus. Let me use another color just to show it's a minus. Okay, so you just put 7 on top of the 1, and then that's how you get your answer. That's how simple it is over here. So then we do it the same with the 2. So the 2 will be on top. We put the 48 at the bottom. And then we also bring the minus because the 2 is not negative. And then since these 2 already have minuses, so the minus and the minus will cancel each other out. So those 2 will just be positive answers. So it will be 4 over 48. And then the other one will be 8 over 48. And you will have noticed that inside this is now the x the power of -1, which is the inverse of this matrix X over here, okay? So the inverse are fractions, and they say that if you multiply the two of them together, we should be able to get we should be able to get an identity matrix, and the identity matrix is something that looks like this: 1, 0, 0, 1. That is the identity matrix that we have to get, okay? This is identity, okay? ID, all right? So we should get an answer like this if we multiply the two of them together. So this means if I say X, I used a wrong letter, but let's see if it will work. X multiplied by X inverse, all right, should give us the ID, all right, equals to ID. Let's call it ID for now, so that we know ID is for identity. All right, so let's test that theory out. We know both of them. This is a 2 by 2 matrix, okay? This is also a 2 by 2 matrix. So we definitely know that we can multiply them out, because the row of this one, the column of this one and the row of this one are the same. So we know we can multiply them, it's fine. So let's just quickly do that multiplication as well. So I will have, let's use, which color is better? Green, okay, dark green. So let's use this one. It will be -8, -2, 4, and 7. And we are multiplying it by, so we normally just use a dot to show we are multiplying it by. And the other part will be -7 over 48. Okay, I think I've made a mistake somewhere. I just realized now, but let's see. Okay, the other side is -2 over 48. And then we have 4 over 48. And then we have 8 over 48. Okay. I'm not sure where the mistake is, but it looks like I've made a mistake somewhere. But let's see if the answers will be okay. But normally it looks like you made a mistake and then you find out you did not make any mistake. Okay, I need to screenshot this quickly so that we can continue our calculations, especially the bottom part. Sorry, screenshot. Okay. So let me just clear the drawings so it becomes clean. And now we go here at the bottom. This is where I want to do the calculations for. So over here, we are saying that we are doing multiplication. So you will know it will be a row by column. Okay, and then again, row by the other column. And then again, row by column. And then again, row by column. That's the way we will do our multiplications of everything. So let us just quickly do that. Let me use a blue pen. So the first one I will have is -8 multiplied by the first element, which is -7 over 48. All right, that is the first element, plus the second element, which is this one over here, which I have -2, all right, times the second element in the first column, 4 over 48. That is your first row, first column. And then we go to the, this is going to be a very big matrix. Sorry about that. Just that. This is going to be a very big matrix. So that is the first row, R1, C1. Okay. First row, column 1, done. Now we go to R1, C2. Okay. First row, second column. So the second one will be minus 8 times first element in the second column, negative 2 over 48 plus second element in row 1, negative 2 times the second element in column 2, 8 over 48. And then we do the same thing for the second column. So there is a trick here that I want to show you guys, how we can do this multiplication method quick. But if you have done the homework, the multiplication method would have been, you will see the trick very quickly here. So this is how we know we are doing a 2 by 2 matrix quick multiplication. So since I know that for this one, column 1, we are always going to use column 1 for this one. So over here, you will always have the same column answer for all of them. So it will be minus 7 over 48. And it will be here 4 over 48. The same thing on this side, the columns will be the same. So it will be minus 2 over 48. And here it will be the same, 8 over 48. Okay, so these columns will always be the same. And then the rows, this is 4 and 7. So 4 and 7 will be the same for the row as well. So you'll have a 4 here, that is the first element, times, and then you have a 7 here, times. Then the same, a 4 here, times, and then a 7 here, times. This is the shortcut. So if you, how did I get to that shortcut quickly? Just to explain. So since you see here, there's a minus 8 over here. There's also a minus 8 over here. There's a minus 2 over here. There's also a minus 2 over here. So it means whatever number I have here, I will also have like duplicated on the other side. So here I will start with a 4 and a 7. And then I will also do the same on the other side, a 4 and a 7. Okay. And then the trick is, this is the rows, okay? The row will be the same. And then for the columns, you will see that it will go down. So if I have a minus 7 and 48, then down of it will also be minus 7 and 48. And then there's a 4 and a 48, down will be 4 and a 48. And then here is a minus 2, 48, down will be minus 2, 48. 8, 48, down will be 8 over 48. So that is how we can quickly do the multiplication of everything that we have. Guys, it's again a short time. We have like 1 minute left. I would suggest we just reconnect so that we can quickly do this calculation so that you can see how it works, and then everything will make a lot more sense. All right. So I'm just going to quickly stop this session because I want to record the next session again. And I don't want to be interrupted as I'm explaining the final part. So quickly reconnect again.